Every time you type a prompt into your smartphone, you're relying on a 20-year-old assumption. We've been trained to think of digital actions as weightless, up in an invisible cloud. But pull back the interface, and you hit physical gears. A traditional internet search is highly efficient. Finding a recipe or pulling up a Wikipedia page requires a microscopic fraction of a single watt. A generative AI prompt operates on completely different math. This scale compares the two interactions side by side. On the left is your web search. On the right is a single request for an AI chatbot to write code or synthesize data. That one request pulls the exact same amount of electricity from the grid as keeping a standard light bulb powered for an entire hour. Move away from text and the consumption multiplies. Generating a simple 5-second video with AI requires enough electricity to charge your smartphone 50 times over. Now, take that single, high-energy interaction and multiply it by billions of human users. Add in the autonomous AI agents and the endless background API calls firing off every millisecond of every day. Look at this sprawling grid of Buenos Aires. Generative models have evolved into entities so power-hungry that maintaining their baseline functionality requires more continuous electricity than the entire nation of Argentina. This transition from simple data retrieval to constant, heavy computational reasoning creates a localized strain on electrical substations. We are using massive amounts of energy for simple chatbots, and current projections indicate we are approaching a snapping point for local power reserves. The physical reality of the cloud is heavy metal and blistering heat. AI lives inside windowless concrete fortresses spanning millions of square feet, hardwired directly into sprawling electrical substations. Inside these walls, the new generation of AI microchips runs so hot that their thermal output resembles miniature nuclear reactors. To prevent silicon meltdowns, data centers rely on massive, high-density liquid cooling systems working continuously. These cooling systems require millions of gallons of fresh water. Tech companies are tapping directly into local aquifers, pulling up clean drinking water to keep their servers from catching fire, and pumping out warm, degraded wastewater. Keeping the digital interface alive requires the active physical sacrifice of a region's most vital natural resources. Outside those concrete fortresses, the public infrastructure tasked with delivering all that power is failing. Much of our electrical grid relies on aging transformers built in the 1970s and 1980s. These older systems were never designed for a relentless 24/7 thermal and electrical load. Under the constant strain of neural network inference, these copper and steel boxes are literally melting and exploding. We're already seeing quiet but increasingly frequent brownouts across major tech hubs. Local municipalities often hush up the true cause to protect heavy corporate investments. This maps a typical power load. For a century, utilities relied on predictable human cycles. Power demand drops when people sleep, but AI never sleeps. Multi-month AI training runs create sudden, massive spikes in global energy demand that utility companies cannot predict. Our mechanical infrastructure and current battery storage technologies cannot bridge this gap. They are not built to survive the unpredictable, constant load of the AI revolution. Because AI requires uninterrupted baseload power, the grid cannot rely on intermittent sources. Solar and wind farms generate power only when the sun is up or the wind is blowing. AI requires electricity 24 hours a day, 7 days a week. As a result, the rapid deployment of new AI compute clusters is negating years of climate progress, swallowing recent global gains in renewable energy. This has triggered a new corporate tactic: energy poaching. Tech megacorporations are outbidding public utility companies for exclusive rights to stable power sources, locking down contracts before the public can even place a bid. Tech giants are now directly buying the rights to entire nuclear power plants, taking that energy off the public market. When nuclear isn't available, they target massive hydroelectric dams, monopolizing the natural flow of rivers to guarantee zero downtime for their servers. The civilian consequences are already happening. Municipal smart city features are being disabled, and residential neighborhoods are receiving warnings about energy rationing, all so private enterprise servers never have to power down. The gap between what human infrastructure can produce and what silicon demands is widening at a high velocity. We are approaching a threshold where the physical wires and transformers in the grid reach their breaking point. We are marching into a harsh ultimatum. If we don't legally and physically restrict the growth of artificial intelligence, governments will soon be forced to make a choice: maintain a multi-billion-dollar AI server farm, or keep a citizen's home heating system running.